Welcome back to my channel. I'm Brian Kafke, and today we're going to talk about Databricks workflows. If you do data engineering at all on Databricks, you need to know all about Databricks workflows. They are the core to doing any kind of data movement and orchestration work on Databricks. Now, I did this video only about a year ago, but so many new features have come out that really transform what was a fairly decent workflow engine into a really good and solid workflow engine. So I'm doing it again with all the new bells and whistles as much as possible thrown in for good measure. So let's jump in. So where are we going? Well, I'm going to start off by pointing to you to a couple of links. I will put a link to the slides, data, and code in the description of this video so you can go get it for your very own and download it and install it yourself and play with it. And there you can also get the link to a YouTube video that was done at the last Data and AI conference by Databricks, and they talk all about the new and upcoming features for Databricks workflows. I also put a link to the documentation about workflows, so that if you have more questions, you want to know how you use them, you can follow up with that. So we're going to talk about what are Databricks workflows. Then we'll do a riveting demonstration of workflows. We'll talk about why use workflows and limitations, and then we'll discuss a few use cases. What are workflows? They define a series of activities to complete a task. So it's going to be something centered around data, most likely. It supports some type of scheduling. With Databricks, you need support for a scheduled time, but also maybe when a file lands in storage or even event hub kind of stuff like streaming scheduling. So you need a lot of flexibility there. It supports logging and alerting, which is logging is you're writing messages so you can track what happened and it will support debugging. And alerting is let me know if something failed or something happened. It supports parallel task execution. Now that's really important because if I have to wait for everything to run in serial, it could take a really long time. I could probably load, for instance, 30 or 40 tables at the same time. There's really no reason to wait for one to be done for the next to be executed. Sometimes you do, but sometimes you don't. And for that optimization, you want to support that, and workflows do. Now, it is not a data movement and transformation service. So new term DMAT. I want to be careful here because this is not such a tool. It is not an ETL, ELT, that kind of a tool. It is an orchestration tool. When you think about actually transforming or moving data, you're thinking of the actual work itself. And if you think of like an orchestra, the Boston Symphony near where I live, you have the actual people playing the instruments and playing the drums and playing the fiddle and all these things. But then you have the person who is orchestrating it, right? The conductor is bringing things in and getting this to play next. That is what the workflow is about. It coordinates the work, but it doesn't do the work. It calls in things like notebooks or Python scripts to actually do the work. So what would this be similar to give you kind of a sense of what we're talking about? If you're familiar with Apache Airflow, that's also a workflow orchestrator. SQL Server Agent is something I used for years on SQL Server. More of a job scheduler. You set up times when it's going to run, but you can set up multiple steps and it will run those steps. If one step fails, you can have it fail the job. You have some control. So that's another similar type of thing. If you've ever used crontab, that's really just more of a job scheduler, but a basic idea is the same. This is, of course, a very simple version, but Windows Scheduler just runs something. Now, I want to be careful because it's doing a lot more than just a simple kick this off at a certain time of day. It actually lets you set up dependencies and a lot of other things that we'll talk about. But put your head on that side. I want to be careful that you're not thinking this is like SQL Server Integration Services or some ETL, ELT kind of tool. So how do they work? Well, they work with something called DAGs. The way we define a workflow is to mentally kind of draw it, and it actually visualizes as well this, but we start with we'll say beginning task A. And from there, we want to go to execute B and C. And we draw lines between these to define dependencies. So A must run in this case before B and C. And you notice it's directed, meaning it's going in a certain direction, right? The circles here are vertices and the lines between them are edges. The edges define relationships to the objects, and we can see, as I mentioned, it's directional, and B can then execute D. Notice B and C can execute in parallel, and C can execute E and F in parallel because there's no dependency drawn between E and F. Let's take a look at this if we were talking about an actual workflow. You can see here we've got this whole workflow mapped out. And the first thing we're going to do is prepare logging. So you can see starting out, prepare logging. The next task is concurrently run task read file 1 and read file 2. Then we're going to, after read file 1 is executed, we can write table 1. And after read file 2 is executed, we can do summary and write table 2. Now those can run in parallel because there's no dependencies between them. So you can see how this is a pretty flexible way to think of and model workflows. We can define what we need done. We can set dependencies. We can set the order. Those are pretty important things. Additionally, we can, sort of independent of the DAG, we can also set how this job will get triggered. I'm going to walk through this, but if you want to follow along with me, the first thing you'll want to do is upload the data file. To do that, in the Databricks workspace, click on Catalog, and then click on Add Data, and then down here, click on DBFS, click on the left tab, Upload File, and then click in this gray area, and then just locate the file, dim sales territory. Very simple, single file. I just want to create a basic demo and upload it. And you can see at the bottom that it uploads it to this location here. That's where you can find it. Mine has an extra number on the end because I've been playing around with this, but you should just see the file name .csv without any kind of extra stuff there. So now go to your workspace and you need to locate where you put the files. And these are the files I've created for you. So if we look at pre-step A, it's just a single statement to do a print. I just want to demonstrate pre-steps and combining tasks. So this one's real simple. Pre-step B is really the same thing. When we look at workflow notebook 01 load to raw, we get some more complexity here. And one of the things that I did in my code is I created a widget using the dbutils widgets dropdown. You can see it here. I'm calling the widget name environment. I'm defaulting it to dev, and then the valid values are dev, test, staging, and prod. I'm doing this because I want to demonstrate how you can pass variables or parameters into your task. So this particular task takes parameters, and I can use the widgets as a way to pass it. Then down here, I use dbutils widget get to get the current value inside the dropdown, and I'm storing it into a Python variable env, just doing a print here, another print, nothing really fancy here. And what I'm doing here now is, remember we uploaded our file. We can do what's called schema on read, which makes it easier to manipulate and work with the files. One of my favorite tricks. So here we're going to say create table, if not exist, dim sales territory using CSV. And then we just basically point it to our file. And I don't want to have to tell it what the schema is. So I'm just going to say infer the schema. You can infer the data types based on the data you see in the file. Header true says the column names are in the first row of the CSV file. So all I'm really doing here is creating a schema for my CSV file. I can't insert, update, and delete rows in this because this file existed before I cataloged it to Hive, which is what I'm really doing here. And it's generating a SQL schema for the table so I can use SQL with it. But it is not a table. It's not like a Delta table either, so be careful there. I'm not able to do inserts, deletes, but I can query it with SQL. And that's what I want to do just to make my life a little easier, because this is the raw layer, right? Medallion architectures take data from somewhere, commonly like a CSV, and load it to raw. And that's my goal here. Now that I've got it as a table, I can use Spark SQL to read all the columns from it, right? Read all the rows and columns. And I'm going to store that in SPDF underscore dim sales territory, SPDF for Spark Python data frame. And you can see here, I've already ran this. I'm just kind of stepping through it before I do the workflow execution. But you can see here, it tells you the type of data and things in there. So it worked. And here, I'm going to take the Spark data frame I just created above. I'm going to use the write method. I'm going to tell it to overwrite using mode overwrite in quotes. That will overwrite anything there. And then I can say save as table. It'll create a table named raw underscore dim sales territory. So that's going to be my initial raw table. Typically, I would be doing this over and over, right? Every time a new file lands, just ingest it and lend it to raw. And then I can take what's in raw and merge that into my transformed layer. Here I can do a describe just to make sure it worked. That's about it. So the first notebook, real simple. Once I got it in raw, that's great, but then I'm going to want to merge it into my transformed layer, and that's what Notebook 2 does. And you can see there's print statements, and I don't want to get too much complexity here. This function is here because I want to check if the table exists before I go to create my transform table, because first time through, it won't exist. I could explicitly just create an empty table, but I'm going to do a check instead, and that's what this function does. So just take a look at that. I don't want to kind of bog down too much, but all this really will do is just return a true if the table exists and a false if it does not. Here I'm going to do a check to see that the raw table exists, and you can see it does. I want to have a variable that checks does it exist. So trans table exists is going to get the result of that function above, and I pass in the name transformed underscore dim sales territory. That's going to come back with either true or false. If it comes back with true, then I'm just going to print a message here saying, great, table's already there. I'm just going to have to merge now into it. But if it doesn't come back with true, it doesn't exist, then I'm printing transform table does not exist. So the easiest thing to do is just say create table if it doesn't exist, which of course I just confirmed it doesn't. Transformed underscore dim sales territory as select asterisk from raw. So what am I doing? Basically, I've got nothing to start with in my transformed layer. So I'm just going to take a copy of what's in the raw, put it into transformed. And the next time I get a new file, I'll be doing a merge, which means pulling in each row of the raw and saying, do I already have this? Then do an update. Do I not have it? Do an insert. If there's some sort of flag set up to tell me, I could also do a delete. So you'll notice the last thing here is saying exit the notebook. Because the table didn't exist, I just copied raw. So I'm going to use this dbutils.notebook.exit and exit the notebook. You might find that a really handy statement, by the way. Sometimes you want to conditionally exit a notebook. Sometimes I'll have code that I haven't really debugged or tested yet. So I'll put something like that and I can get other pieces working and set markers within the notebook where I want it to stop for testing purposes. So that's what that's going to do. If you get to this point, that means the table already existed and we can do a merge. We're merging into our transform tables dim sales territory. We're going to be using our raw sales territory. This is basically just a short name or alias for the table name, so I can refer to it a little easier. Same here, raw. And you can see I'm matching on keys. Raw sales territory key equal transform.sales territory key. If I get a match, then I'm going to do an update, and it's just going to update all the columns. And if I don't get a match, then I'm doing an insert. That's really it. Finally, I've got my transformed. And this is very simple, but you kind of imagine a pipeline here. Finally, I'm going to do the semantic layer. Semantic layers are really suited for things like getting the data prepared for something like Power BI. Now, Power BI and similar tools really want to have a star schema. So typically you're going to aggregate, you're going to kind of consolidate your dimension tables into very few tables and create that sort of star schema. That's the ideal way to do that. Now, I'm not going to do anything fancy. I'm just going to demonstrate because it's more about the workflows. So I'm going to say drop table if exists, semantic dim sales territory. And here I kind of overdo it too because I say create or replace table. So if it did exist now, it's just going to replace the table. Then I can do this query and that's about it. So the idea would be that this semantic dim sales territory summary is something used by something like Power BI or some sort of dashboard. Now we have our code. Let's go look at creating a workflow. I'm going to cheat here for a minute and I'll show you what the end workflow looks like. You can see we have our pre-task, we have a task after that, and then the task after that, and the task after that. That's what it looks like when we're done. I can zoom in a little bit. You can see that we have this nice little DAG, right? It's what it is. It's a little different, a little more block size than the circles I used, but it's a DAG. And you can see that we have each task and then dependencies between them. So the first thing it does, it runs script 1 and script 2 that I showed you. Those are just very simple single line scripts in Python that say print. Here I'm going to say run in notebook, which is load. This is raw bronze, then transform, then semantic. And I'm going to run that now, and then I'll walk you through creating another workflow, but it'll do the same thing. So let's kick a run off. And while that's running, I'll walk you through creating that workflow, similar type of thing. So let's create our first workflow by clicking over here under workflows, create job. And the first thing we can do that they don't really call attention to, but you want to give your job a name. So we'll call this demo workflow. And then we need to give our task, our first task, a name. It automatically starts on editing a first task, and you need to save the first task before you can really do anything else. It's kind of a starting stub, and you have to get that established first. So the first thing we're going to do is say pre-1. That's the pre-step 1 that we did earlier, right? It's not a notebook, right? It's a script. So we're going to say Python script. And it's in a workspace. We could go to like a repository or something to find it, but we're going to go to a workspace. And here we can just navigate to where we have it. So under YouTube is where I have mine. I'm going to go here. And the first one, run, I call it pre-1, but this is pre-step A, right? It has a cluster is going to be created for it. I'm going to let it use the default, but I can go in and make any changes I want to my cluster. In fact, I will be lazy. I'll cheat and I'll use a single node. It says use photon acceleration. If you have something that isn't compatible with that, then you may have trouble with photon, but seems to be okay there. I can add libraries. Now, these libraries would be specific to my task. This is really nice because maybe you don't want to have to keep installing the libraries on the cluster. You're using it just for the job, and you can just click in here, and you have all this flexibility about what libraries you want to install just for the task. You also have parameters here that I can, manually type in, but I do need to use, at least my experience, I do need to use the widgets as a way to sort of sync up to those parameters. And finally, we can add emails. So we can say add to this. We can say, do we want to add emails? So we can say on start, on success, on failure, or if it just takes too long to run, we can set a duration warning. Most people want it to be on failure. Sometimes having it like on success can be useful if you're early on, it's a critical production thing, you just put it in. I've done this sometimes in the old SQL Server world where I'd like to get an email just saying, yeah, it ran, especially if it's like once a week and it's critical it runs. Getting the success is kind of nice because if something goes wrong and I don't get a failure message, I may not know something isn't working, but the success kind of is the other side of that. But it's up to you. You've got all kinds of notifications. I can mute notifications on skipped runs and mute notifications on other things. So you have options there. I can also set how many times to retry. I can set that duration threshold if I want. How long do I want it to wait? So I've got all these options, and all I want to do now is set off the create. The create's going to create sort of a stub version of the workflow. I don't really have a workflow yet until I click on that. And now you can see, okay, it saved it and it shows the task, and the add task button is enabled. I want to call your attention on the right, though. We have a lot of things here. We've got a job ID. This is the overall workflow. Shows the creator. I can say run as, and I can change now workflows to run as a service principal and some other options here. So I can do a bunch of things here, but by default, it's going to come up as me. I can add tags. So I can say that this is, like cost center 1, 2, 3, 4, 5, which might be useful, can be useful for a lot of things. Tags are good ways to sort of track things, sometimes use it for billing purposes for Azure and things. Can add a schedule. Here I can say it's scheduled, or I can say continuous if it's like a streaming job. So if I say schedule, then I get this whole interface where I can set when I want to run it, days, weeks, etc. So I have all that flexibility there. Compute here is the job cluster. So I can set up a job cluster, compute, and define what I want to configure from my job cluster. And swap is kind of handy. I've used swap mainly in test. Sometimes it really gets tedious when you're testing a job and it keeps breaking, and then you have to wait another 6 or 7 minutes for a cluster to get created just to see it fail again. So what I sometimes do is on the job, if I'm really editing the notebook and not changing the job too much, I can swap out the compute. And in dev, I'll just have a cluster that's running. It will time out maybe an hour, but it's just going to be there running. And by swapping and pointing to it, I don't have to keep waiting for it to start a new cluster each time. In prod, maybe I don't want to do that. It all depends on your needs, but it's really handy, I find, for testing. So here we can set how many concurrent runs will be allowed. In ETL workloads, in my experience, most of the time, you'll end up with locking and things if you allow that. So by default, it doesn't allow that, which is, I think, a good idea. You can set duration thresholds. And again, on the job level, you can set notifications, start, success, failure, and things. So you get that at the task level as well as the job level. Now we've got pre-1 loaded. Now let's add another task. And this is also going to be a Python script. But let's take a look at the task types we have, because I kind of skipped over that. We have a lot of options. Some of these are not enabled, like for me yet code. I don't know what that is. I'm guessing it's a future option. We can run notebooks. We can run a Python script, which we've done. We can use a Python wheel. We can use a jar. We can do Spark Submit SQL, so we can submit, if we've got it set up for that, we can do SQL statements directly, dashboards, just run a query, SQL query, alerts. We can set up an alert task. We can set up something for a SQL file, like a SQL file script, I believe. There's some new things coming up, looks interesting, data transformation steps, and then Delta Live Table Pipeline. And I want to call your attention to these two in particular. The Delta Live Table pipeline, really, really important. They added this because Delta Live Tables is becoming a pivotal part of Databricks, right? But it's not designed for every scenario. Sometimes you may want to do the more traditional workflow and run notebooks that will say prepare the data and get it to a certain point. Then you want to say, okay, Delta Live Tables take over from here. So we have the option of creating, as part of our overall workflow, running Delta Live Table pipelines, which are Delta Live Table jobs, really. And it's a completely different world and a different engine, but the fact that we can intermix the two in a single workflow is really powerful and important. Another thing here that they added, which is very cool because a lot of people use this, is DBT. But I have to be honest, my favorite feature, one that I requested in my last video, and they've added, is the ability to run a job from a job. So I can go in here and say, I want to create a job that will run a job. I should not have done that yet. I'm not ready. I'll cancel it. But the point there is I can fire off another job. Now, why that's important is because it gives you reusability, modularity in your jobs, not just your code. I may have a series of steps that recalculate my semantic layer. And there's a lot of different jobs out there that need to kick it off because sometimes this area comes in and gives me more raw data, and sometimes this happens or that happens, and I want to refresh my semantic data when any of those things happen. So the ability to say, here's my semantic data refresh job, and just have people add that in when needed in other jobs is huge because I can maintain it in one place. I don't have to recreate that logic. All right, so let's kind of build up my job here. I'm going to say add task. And I'm going to say in this case, it's another Python script. And I'll give it I'll just say what did I call the other one? Pre-step. I'll say 2. I think it's B. Then you see Python script. It's in my workspace. I'm going to find it, confirm. And again, you can tweak your job cluster here. You can make changes here. Dependent libraries, just as before. Say create the task. Oh, and I need to do one other thing. I need to call your attention to, notice by default, it automatically assumed it set up a connection between step 1 and step 2 as a dependency. But actually in this case, I want these to run in parallel, so I need to delete that. And now you can see they're not connected. Perfect. I'm not going to do the emails and the retries and all that stuff, but pretty cool. And I need to say now create task, and it did. Perfect. Now I want to start getting into the really guts of my ETL work. So I'm going to say add task. This time it is a notebook, and I'll say the task name is load. We'll say the raw layer, right? It's a notebook, perfect. The source is my workspace, but again, you could be pulling from GitHub, Git, whatever. You've got a path here. I'm going to find it, and here it is, load to raw, right? Cluster's fine. Again, parameters, all that's good. And it says pre-step 2 is a dependency, and that's fine. I want to have pre-1. All right, I didn't name these too good. I should have said pre-step 1, pre-step 2, but you got the idea. So those are 2 dependencies, and you can see now it's showing 2 different things coming in, and I could keep adding as many dependencies as I need. I need, of course, to have the task available before I create the dependency, but there it is. And I can say here, run if the prior one succeeded, if it's at least one of these 2 succeeded, if none of them failed. A lot of variations here. Some of them seem a bit similar in wording, so I'll have to play with that, I think, and see what the differences are, but that's pretty cool. And I can say, okay, create the task. Okay, and then I'm going to say add another task. And this one's going to be also a notebook. This will be load transformed. I'll go over here and I'll say the path. Okay, that's there. Create task. And it's building the dependencies one after the other, which is pretty handy. And finally, I've got one more notebook I need to add in here. And this one is going to be load semantic. Okay, there it is, dependent libraries, parameters, looks good. And each time, in order to do editing on the other tasks, you need to save that task you're on. Now I actually, on the load table, that's where I need to set up my parameters. So let me take a look at that again. But when you're doing parameters, it's actually telling you, sort of hinted, you want to put the dictionary type of format here, and then put your parameter name and value in quotes. But here I want to do this and then say environment. And then here I want to say, we'll say prod. And if I didn't make any mistakes, that should work. And then I can just say, okay. And pretty cool. So we got a lot of options here. I think the most important thing when you're doing tasks, though, is that I want to really highlight is all the different options we have here. The ability to kick off so many different types of tasks, including jobs, DBT, SQL. There's a lot more flexibility here. And there's a big emphasis and really cool thing on dashboards. I haven't used dashboards nearly as much as I think I should because they're pretty powerful. They've gotten a lot better in Spark over time, and Databricks in particular, I should say. And now you can just say, I want to refresh your dashboard as part of your process, and it will refresh the dashboard for you, which is really nice. All right, I'm going to try to run this. We shall see if it works. Now you can see it's triggered. If I go to runs, you'll see that it shows green. It doesn't mean it's actually working. If we highlight, you get actually all this kind of information, and you can see the task. You'll see each iteration over here if it tries to run. And here you can watch it. Now, if I want to actually watch an iteration running, I need to click on the link and then I can see what's going on. And here's the biggest thing you're going to spend time watching. It's creating the cluster. So it probably takes 5 or 6 minutes. Then it creates the cluster, and then you learn if it broke anything or not. So let me go back here for a moment because I can go back to my ETL job here, or ELT, and that ran successfully. There it is. See, everything ran. Now let's see if I coded correctly the way my pipeline should have worked. I can't see the task. If I go to task, let me check this for a minute. Okay, so interesting. I didn't see the UI pop up when I was looking at this. This would have been a little easier than using the JSON approach. But it looks like I did it correctly. Hopefully I did the capitalization. So this is how it's setting the parameters. You can do the UI approach here, and that's a little bit easier. I used the JSON in my actual recoding attempt, but you can see it ran through this whole thing. And if we look at a given run, we can do that here. I can click into any one of these things and I can see like the output. It's particularly powerful though when I look at a notebook because I can click on the notebook and it shows me the notebook with all of its outputs. So it's as if I ran through my notebook in debug mode. More or less, I can see all the output. You can see it's doing this. It told you how long it ran. This is really good. I like this a lot because when I'm debugging, it's really handy to see like, oh, some error message. Oh, this worked. Sometimes I will even in test mode like do describes or queries just to see that things are looking good. I can remove them once I get more to stable code and ready to move it to prod, but it's really handy to be able to do that. You can see here, it gives you the link to the notebook. Oh, a good thing too is if it fails, which we should probably take a look at, you'll be able to just click into the notebook and fix it and run it again. So maybe I should trigger an error so we can see that in a moment. And I clicked in now, I'm watching it, the cluster's up and running, and you can see it's done the first 2 steps. I love watching them run. I don't know what it is, but it's pretty cool to see the boxes go green. I cringe when they go red, but you can see as it's running things. The way this looks when it's running too reminds me a lot of SSIS, SQL Server Integration Services. All right, cool. So you can see everything ran. I'm going to particularly take a look at this to see if my code actually worked. You remember we set up this DB utils in the code. That's great. And then I did env here, right? And notice it says it's running in prod. That's important because let's look at this closely. When I set up by default, I set it up to default to dev. And in fact, it was set to dev when we were in there. And yet then here, I'm saying get the widget. Why did it change? Well, it changed because I set a parameter. And you do need widgets. At least my experience so far is you can't just pass parameters without setting up widgets to get those parameters. So kind of something to be aware of. You can see here, I just want to highlight this one more time. When it prints the environment, it says prod. Now let me show you why it did that. Because if I go into the demo workflow and I go into the task here, the parameter here says prod. That's why it did it. And if you do JSON format, that's how it looks. So it worked. It took my override. You may be asking yourself, but how do I pass parameters dynamically? Can I do that? Can I change things? Can I tweak them? You can. The workflow service has a complete REST API that lets you do pretty much anything I can see. It's a really good way to automate things. So if you wanted to create workflows programmatically in like a Databricks notebook or something, you can do that and then just use the REST API to stamp out your code. And that's also a good time where you can define task parameters or stuff. Now, if I look at runs, you can see it shows the run here. I can get different statistics. See here, you get the run information here as well. And one of the things I want to highlight is that if I wanted to, I can also go into the logs. And when you get stuck, it can be really handy to like look at, what's going on here and try to figure out like where's the error coming from. Not always easy. There's other ways to do it, but I still find that I'm often looking at the logs when I'm debugging things. One thing I do want to show you before we leave is let's just trigger an error and see how we can correct it and fix it. I'm going to do something really dumb. I'm just going to go over here and get rid of this end quote because that should trigger an error in Python, right? Then I'll go to my demo here and I'll say run now and I'll just run the job. Okay, I wanted to show you what it looks like when you get a bug. I never get them, but if you do, no, I get them all the time. And it's actually kind of nice because you can see clearly where it went wrong in this notebook. But usually if you have some sort of basic error, you'll see something like this on terminated literal, which is pretty useful. And you can just click on this, like go to highlighted error. It didn't get you exactly there, right? But it got you close. Here you are. So I can basically just use this link back to the notebook to fix it or go back where I had it open. Then I can go down to where the error is, like that. And what I really wanted to show you was then I can say repair rerun. So now that I fixed the error, I can just say repair rerun. And I'm not going to wait around for that, but trust me, if you fix it, if it's right, it'll repair rerun. You can also just say rerun from the beginning. What's nice about doing the repair rerun is that if you had a long job run, it will pick up where it left off and you fixed it and continue. In a short one like this, it's not really important, but imagine you're waiting 3 hours or 4 hours and now you got to wait again all over again. All right, so we got an idea of workflows. I hope I showed you things that you'll like. I actually had to turn on premium from my workspace in order to get the Delta Live tables to show up. So bear in mind, Delta Live tables require a premium workspace. So why use workflows? Well, there's zero effort to set up the workflow service, right? It's built into Databricks. You've got it. It's free essentially because it's there and you just use it. It can execute many types of tasks, and this has been a massively improved area from even a year ago. And it's highly configurable. We can set up options to notify, we can log, we can look at things. We've got a lot of built-in logging tables that I barely touched on that show you what's happening. It's all integrated into your Databricks environment. It fits into the Databricks roadmap. Now, why does that matter, Brian? Because Databricks isn't sitting still. Trust me, I can barely keep up with all the stuff they're doing. With that in mind, if you suddenly say, it doesn't do one little thing I need, I wanted to get a nice purple font here and I couldn't get it, and you don't use workflows because of that, you could be investing a lot of effort and energy in some other technology only to find yourself a few months from now, a year from now, or even tomorrow, realizing they finally give you that, or it can do 99% of what you need, and it's so much easier. It's all built into Databricks. It's all integrated. It's going to be a lot cheaper in the long run than using something like Airflow. It's also a no-code solution, which is a big thing for me. You can do coding around it, as I mentioned. You can use the REST API. I think I have a bullet for that. But I'm not a big fan of having to write a lot of code to run my code. And that's one of my criticisms I put on Airflow, for instance. You have to write a lot of code just to run your code. So Workflows is built into Databricks. And as I mentioned, fully supported with a REST API. So are there any limitations, Brian? Are there anything that can't do? Well, yeah, I guess there's a few things. It's only available on Databricks. May seem like, well, obviously, but what I mean by that, it is not available in open source Spark. So you are committing to Databricks when you use Workflows. It is ideally suited for Databricks workloads. And what I mean by that is if you're doing 90%, say, Synapse on Azure or BigQuery or other things, and you're not really focused on Databricks, Delta Lakehouse, Delta Lake, and things like that, it may not be the best service for you. It may not fit extremely complex workflows. I have not hit this level. I have to admit, I'm the sort of meat and potatoes data engineering guy that goes way back. And so typically I see more the medallion architecture, bring data in, you massage it, you clean it, you put it over here. You may have a lot of data, you may have certain use cases, little edge cases, but mostly what I see. But I got feedback on some of my other videos where people said they have like 1,000 different tasks and each task has to look at things and figure out dependencies before it runs another thing. And if you get something that's really a hairball of complexity to run, I don't know what's an answer. It does seem like Airflow is ideally suited for those cases where you really need very granular control. What are they good for, Brian? Data movement and transformation, DMAT. I'm going to make this a new acronym. That is what they're good at. They're good at orchestrating data movement and transformation. Perfect for that kind of stuff you typically do. If you're doing the medallion architecture thing, the medallion pattern, bronze, silver, gold we did, I think they're ideally suited for that. Machine learning pipelines, they're great for that. You can hook in all these different tools, ML ops, and all this great stuff and move it in. Also, if you're preparing data for visualization tools, creating those semantic layers, it's also really good for that because you can set it up on all different types of refresh conditions, triggers, right? You can set it up on a timetable, like every hour, every 2 hours. You can set it up when there's new data coming into, a streaming source like EventHub or Kafka. So you have a lot of control there, and you can easily generate and go through the layers to get to your semantic tables, which are ideal for things like Tableau and Power BI. And kind of separately, but if you need to do any kind of Databricks automation, maybe, doing optimizes and things on tables or just kind of maintenance tasks, refreshing dashboards, those types of things, it's really good for that as well. So wrapping up, we started with the question, what are Databricks workflows? And we learned that it's a job orchestration engine. It is not really tied to doing things in data, and it doesn't really mangle or transform data itself, but it orchestrates the work of processing data, the conductor of an orchestra, just coordinating that work. We did a good demo. I hope you liked it. You got the code, you can play with yourself. But the question is, why use workflows? Because they're there. Why climb the mountain, right? Because it's there. Workflows are there. They're in Databricks. They're actually very powerful. Even if it was a separate service, I would probably pay for workflows extra as opposed to using alternatives because it does such a great job of just integrating everything, runs fluidly, and can pull in all the things I can think of I'd want to in most of my jobs. There are, I'm sure, some percentage of jobs it won't handle, but it does the bulk of it. If you're looking to be a data architect, you need to really look closely because the word I always use is parsimony. You want to take the simplest solution and only make it as complex as necessary to solve a problem. Limitations. We talked about things it's probably not ideally suited for. If you really have a lot of complex dependencies, it may be a little too much. And the UI is it could be hairy. It doesn't have a UI that's very easy to really control if you're doing like thousands of tasks. You could kind of see it could be kind of awkward trying to find a lot of different tasks within a really large workflow. Use cases are your standard kind of data engineering use cases. That's it for this time. Please like, share, subscribe. And until next time, I'm pulling for you. We're all in this together. Thank you.